Hello everyone. In this video, we are going to see about the subject Control System, Unit 3, Frequency Response and System Analysis Introduction. Objectives. At end of this video, we gain a knowledge of about various methods for analyzing the frequency response as well as the system stability. Now let us talk about the frequency response analysis. In general, the response of a system can be partitioned into transient response and steady state response. This transient response can be found by just applying the Fourier integrals in the given transfer functions of the systems. And the next one is frequency response. This frequency response is the steady state response of a system for an sinusoidal signal is known as frequency response. How means if a sinusoidal signal is applied as an input to the linear time invariant system, then it produces the steady state output, which is also a sinusoidal signal. In frequency response analysis, we can vary the frequency of a input signal over a certain range and study the resulting response is known as the frequency response analysis. At last, the input and output sinusoidal signals having the same frequency, but it will have different amplitudes and phase angles. Then, to understand the frequency response better, let us consider what are the applications of frequency response analysis. Generally, in industrial control system, the characteristics and performance are analyzed by using the frequency response analysis. And in other applications are the frequency response analysis is used in numerous systems and components such as audio and video amplifiers, and then speakers, sound cards and servo motors. At last, one of the main applications of our frequency response analysis is, suppose the noise which is always present in control systems. This noise will result in poor overall performance, and that situations the frequency response permits analysis with respect to this. So these are all about the frequency response analysis characteristics. Next, we are going to see about the advantages of frequency analysis, and where we used frequency analysis means the first one purpose of the frequency response analysis is the stability of the control system can be estimated using frequency response, as well as the transfer functions of the complicated system can be determined experimentally by using frequency response. And then the one more foremost advantages of frequency response analysis is the effects of noise disturbance as well as the parameter variations are relatively easily to visualize in terms of frequency response analysis. And then this analysis can be extended to certain non-linear control systems also. So these are the advantages of frequency response analysis. Then frequency domain specifications. What are the specifications means? The first one is resonant peak, and then resonant frequency, and then bandwidth, cutoff rate, gain margin and phase margin. These are the specifications we are generally used in the frequency domain to analyze the purpose of our control systems. The first one is resonant peak. What is mean by resonant peak means the maximum value of the closed loop transfer function is known as resonant peak. And then the formula to find the resonant peak is generally denoted as MR, that is equal to 1 divided by 2 zeta into square root of 1 minus zeta square, where here is zeta is the representation of our damping ratio. And then the one more point about the resonant peak is a larger resonant peak corresponding to a larger overshoot in the transient response. And the next one is resonant frequency. What is meant by resonant frequency means the resonant frequency is a frequency at which the resonant peak occurs is known as resonant frequencies. And then formula for resonant frequency is omega r equal to omega n into square root of 1 minus 2 zeta square. Here omega r is our resonant frequency and then omega n is our natural frequency and then zeta is already we know, that is our damping ratio. And then resonant frequency is the indicative of the speed of the transient response. And then the next frequency domain specification is our bandwidth. Generally, bandwidth is the representative of range of frequencies for which the system normalized gain is more than minus 3 dB is known as bandwidth. Here the formula to find bandwidth is bandwidth equal to omega n into the whole square root of 1 minus 2 zeta square plus square root of 2 minus 4 zeta square plus 4 zeta power 4. This is the formula to find the bandwidth of the frequency response analysis. And then the bandwidth of the control system indicates the noise filtering characteristics of the systems. Also, this bandwidth gives a measure of the transient response also. And then the next one specification is cutoff rate. Here the cutoff rate is the slope of the log magnitude curve near the cutoff frequency is known as cutoff rate. Then the cutoff rate indicates the ability of the system to distinguish the signal from the noises is known as cutoff rate. Then the next one specification is our gain margin. Here the value of the gain added to the system for what means in order to bring the system to the verge of instability is known as gain margin. As well as the gain margin, it indicates the additional gain that can be provided to system without affecting the stability of the system. And then the gain margin for higher order system, that is our second order system, is always infinity. This point we will use in our problems. And then phase margin. The next one is phase margin. Here the gain margin is the value of the gain added to the system for what means to bring the system to the verge of instability. The same similarly the phase margin is known as additional phase lag to be added from where means grain crossover frequency for what means in order to bring the system verge of instability is known as phase margin. Here the phase margin indicates the additional phase lag that can be provided system without affecting our stability. And then what are the methods we are using in frequency response analysis means, that is called frequency response plots. Here the frequency response of a system can be carried out either analytically or graphically. This frequency response plots are used to determine the frequency domain specifications. What are the specifications means we are already seen in our previous slide. What are they means? Bandwidth, cutoff rate, phase margin, gain margin, resonant peak and then resonant frequencies. These are the specifications we are find by using this frequency response plots and also to study the stability of the systems. The various graphical techniques used for frequency response analysis are: the first one is Bode plot, polar plot, Nicholas plot and last one is M and N circles. And now let's discuss a short description about above the listed plots. Here the Bode plot and the polar plot and the Nicholas plot are usually drawn for only open loop systems. From this open loop response plot, the performance and specifications of closed loop systems are estimated. And then the last one, MN circles and then Nicholas chart are used to graphically determine the frequency response of closed loop system from the knowledge of the open loop system. Then the first one is Bode plot. Here the Bode plot is the frequency response plot. In this frequency response plot, it contains two graphs. One is magnitude plot and then other one is phase plot. The first plot, the magnitude plot, is drawn versus between our sinusoidal transfer function versus our logarithmic value of our frequencies. And the other graph represents the phase angle plot, and it is drawn both for open loop system as well as for closed loop systems. So these are all the short descriptions of our Bode plot. This will be briefly discussed in our upcoming video. And then second one is polar plot. It is otherwise called as Nyquist plot. This polar plot is the plot of the magnitude of the given transfer function to its phase angle on the polar coordinates. Generally, the frequency of the polar plot is varied from 0 to infinity. Then this polar plot is drawn on the polar sheet. This polar sheet is nothing but it is also a one form of graph. This graph consists of concentric circles as well as the radial circles. Then why this polar plot or otherwise called as Nyquist plot means, in what sense means, the extension of the polar plot is known as the Nyquist plot. Then the frequency in the case of Nyquist plot will varies from minus infinity to plus infinity. But the polar plot, this frequency range is 0 to infinity. But in Nyquist plot, the frequency range varies from minus infinity to plus infinity. So these are all about the short descriptions of our polar plot. And the next one is M and N circles. Generally, the Nyquist plot is used to determine the stability of the open loop system, but it does not provide the exact value of the given transfer functions. So hence for this purpose only we are going to use this Mn circles. So this M and N circles in circuit theory were introduced by our Albert C. Hall. Then the next one is the M and N circles are used to obtain the values of the closed loop functions, but it is obtained from the Nyquist plot only. And then it is also used in the design of the control systems. And over the Nyquist plot, the plot of M and N circles is created. Then the intersection between these graphics provides the value of the closed loop transfer functions. So these are all about the M and N circles. The next one is Nicholas chart. This Nicholas chart is used to determine the stability and then frequency response of our control systems, that is in specifically closed loop control systems. And then Nicholas chart is the plot of the gain versus our phase angle. In addition to this, the various parameters such as our frequency domain specifications, resonant frequency, bandwidth, gain margin, etc. of the closed loop system can be determined from the open loop plot of the Nicholas chart. And then the one more important point in the Nicholas chart is, if the plot of the Nicholas chart and then Mn circles is superimposed, means the intersection of the both curves of the respective plots, it determines the phase angle and the magnitude of the closed loop frequency response. So these are all about the frequency response plots. So these are the references I used to make this video effectively. Thank you.